Assalamualaikum warahmatullahi wabarakatuh. So we are going to start with a new topic on sheet metal working process. In sheet metal working, there are three main processes, which are bending operation, dip or cup drawing, and also shearing process. So other than that, we're going to look into the miscellaneous processes related to the sheet metal working. For our lecture today, we are going to cover the process in this sequence. We are going to look into the cutting operation, which is the shearing process, and then bending operations and drawing process. Other than that, we're also going to look into the sheet metal forming operation. Sheet metal working can be defined as the process where cutting and forming operation performed on relatively thin sheet or metal. The thickness of the sheet metal is usually between 0.4 mm to 6 mm. Usually, the thickness of plate stock should not exceed more than 6 mm, and the operation usually performed as cold working. Among the products of the sheet and plate metal usually are used in the automotive and in the truck making for the body, okay, and then they are also used in the airplanes industry as the body of the airplanes itself, and then it can also be used in the railway car and locomotive, farm and construction equipment, small and large appliances, office furniture, computer and office equipment, and many more. These are just example. If you look around yourself, you will see a lot of product that being produced through the sheet and plate. So now let us look into the advantage of sheet metal part. Why do people want to produce product using the sheet metal part? Okay, so among the advantages will be in term of the high strength, because it's performed in the cold working process, and you will be able to get a good dimensional accuracy using the sheet metal working process, good surface finish, and relatively low cost and economical mass production for large quantities. Before we go further, you have to look into these terms and terminology that are used in the sheet metal working. The first one is punch and die, which are the tooling that used to perform the cutting, bending, and drawing process. Okay, so stamping press is the machine tool that we use to perform the most sheet metal operation, and finally stamping, which is the sheet metal product itself. So the basic type of sheet metal processes, there are three main processes. The first one is cutting. The cutting process is whether it is shearing to separate the last sheet. It can be blanking to cut part perimeter out of the sheet metal, or punching to make holes in the sheet metal. Okay. The second one is bending, where we strain the sheet around a straight axis, and the third one will be the drawing in order to form a sheet of into convex or concave shape. Let us look into the first operation, which is the sheet metal cutting. Okay, so in metal cutting, we are going to look into the steps and the things that happen during the cutting of the sheet. Okay, so if you look into the diagram that shown here, okay, in the first one you will see that this is the die and also the punch. Okay, so there will be a force that will be given in the operation here in this device, okay, on the punch here. Okay, and this is the sheet metal. Okay, what happened is this is before the punch contact with the work. When we apply the velocity and also the force on the punch, there will be plastic deformation happen on the sheet metal working. Okay, so then there will be penetration, it will go deeper, and finally there will be fracture that will be initiated at opposing cutting edge to separate the sheet. Okay, so in the end the sheet will be cut from the main part. Okay, the three principal operation that use in press working that require for the cut of the sheet metal are shearing, blanking, and punching processes. The first process is shearing operation. So shearing process, usually the setup is like this one. If you look into the what we call in, this is the side view, okay, and then this is the front view of the what we call the shearing operation. So you will see that there is a shearing punch with incline what we call upper cutting blade. Okay, so what happened is this is the sheet, and then when we apply the velocity and also the force on this sheet metal, okay, so it will cut away the sheet in here. Okay, so this is how the shearing operation take place. Blanking and punching process are quite the same. Okay, so but then the difference will be in the blanking we are removing a part from the sheet. Okay, so this is the part that the blank or the final part that we want. Okay, so the remaining from the sheet will be scrapped. However, for punching is this is the what we call the material that going to be a part, and then we remove the something from this sheet. So and this part will be the scrap. Okay, so that's the difference between blanking and punching. When we perform the sheet metal cutting, the distance between the punch cutting edge and also the die cutting edge is very important. Okay, so typical value range will be around 4% and 8% of the stock thickness. And then if the the distance is too small, it will cause fracture line pass to each other and cause double burnishing and large force. If it is too large, the metal is pinched between cutting edges and they will cause excessive burr on the work part. Recommended clearance is usually calculated by using this equation, which is C equal to AT. C is the clearance itself, okay, and A is the allowance. There is a certain allowance for each type of material. We're going to look it inside the next slide. And the T is the stock thickness. Okay, so this is the calculation for the clearance. Now for the A value, it is based on the metal group. Okay, for example 1100S and 5052S aluminium alloy, which is being tempered. The A value is 0.045, and then goes for this aluminium alloy, brass, soft coal roll sheet, soft stainless steel. It is calculated, the allowance is 0.06, and cold rolled steel, half hard stainless steel is much higher, which is 0.075. Now let us look into the punch and the die. Okay, so if we want to look into the size of the punch, okay, so in here this is the size of the punch. We declare it as DH. Okay, and die size diameter will determine the blank size, okay, which is the dB. Okay, so this one is dB, which is the die size, and C is the clearance. Okay, so in here there will be calculation for the punch and die sizes. So we're going to look into the equation for calculation of this. Now let us look on the calculation to get the what we call the punch and the die size. Okay, so if let's say we want to create a round blank of the diameter dB. Okay, so we already know that the die what we call the blank diameter is dB. So in order to get the punch diameter, it is supposed to be minus 2C. Okay, so and then where the C is the clearance. Okay, so for if we want to create the hole with the diameter of DH, Okay, so for the whole punch diameter, it is calculated is equal DH. The whole diameter, the whole die diameter will be DH plus 2C. Okay, so where the C is the clearance. Apart from that clearance, we also need to know about the angular clearance. Okay, so the purpose of angular clearance is to allow the slug or the blank to drop through the die. So if you can see here, this is the straight portion of the die. Okay, so on the bottom side here, there will be angular clearance that we have to create on the die. Okay, so the typical value for this angular clearance will be 0.25 degree to 1.5 degree on each side. Okay, so so that when we perform the what we call the punching or the blanking process, it will be easier for the blank and also the slug to drop on this area. Now, let us look into the cutting forces in the sheet metal working process. Okay, so for the F, it is calculated by using F equal to STL, where S is the shear strength of the metal, T is the stock thickness, and L will be the length of the cutting edge. Okay. The second process that we're going to look into is the sheet metal bending. Okay, so what is sheet metal bending? It is a process where we strain a sheet of metal around a straight axis in order to make a permanent bend. So metal on inside of neutral plane is compressed. Metal on the outside will be stretched. Okay, so this metal will be stretched and this one will be compressed. Okay, so this is the diagram that we have you have to look into. Okay, so there is alpha, which is the bending angle. Okay, the R is the bending radius. Okay, so this is the neutral axis plane and also the width of the sheet. So there are two types of sheet metal bending. One is V bending, which perform with the V-shaped die, and another one is H bending, which perform with the wiping die. We're going to look into the process later. Here is the V bending process. So if you can see in here, the punch here with the shape of the V here, and that's why it is called V bending. Okay, so what happened is this is before the bending process, and this is the sheet metal working, the sheet metal. Okay, so when the punch going through this what we call the die, you will get the sheet with the bending of V shape like this one. Okay, so application usually it is used for low production. Okay, so and it is performed on the press brake, and also V dies are simple and very and inexpensive. And here is the edge bending. Okay, so if you can look into here, this is the sheet, this is the metal sheet, and there will be pressure on this part where what we call as pressure pad. Okay, and then there will be a punch that will bend the sheet over here. Okay, so instead of cutting, this is more to bending of the edge. Okay, so then you will get the shape like this one. So this process usually used for high production process, where the pressure pad required for this to hold the sheet metal, and these die are more complicated and costly compared to the V bending. So let us look into the stretching during the bending. So when the bend radius is small relative to the stock thickness, metal will tend to stretch during the bending. So it is very important to estimate the stretching so that the final part will get the specified dimension that we want. Okay, so the problem is it is difficult to determine the length of neutral axis of the part before the bending process. Due to that, we have to calculate the bend allowance. Okay, so the bend allowance formula is given like this one. Okay, so this is the band's allowance AB. Okay, is calculated by 2 pi alpha. Alpha is the band angle, R is the band radius. Okay, so KBA is the factor to estimate the stretching. Okay, this is calculated, this is determined by using this factor. Okay, if the R value is smaller than 2t, okay, t is the stock thickness, so the KBA will be 0.33, and if R is bigger or equal to 2t, so KBA will be 0.5. Okay, so by using this equation we will be able to get the band's allowance, the bending allowance. Okay, now one of the problem when we perform the bending operation is called spring back. Okay, spring back is increase is in the angle of the bend part relative to the included angle of the forming tool. Okay, meaning that the angle that the angle of the part that we bend is bigger than the angle of the forming tool that we use after the forming tool is removed. Okay, so the reason for the spring back is when the bending pressure is removed, there are remaining elastic energy remain in the bend part. This will cause the what we call some part of the sheet metal working to recover to its original shape. When the spring back happen, it will decrease the bend angle. Okay, so it will decrease the bend angle, and it can increase the bend radius. Okay, the radius here will be increased, but the angle will be decreased. Okay, so during bending, work is forced to take radius r here. Okay, so when the operation happen here, uh, the punch will put pressure on the sheet metal to get the R value here and angle alpha B here. Okay, however, after the punch is removed, when the work will spring back to get the radius R and the angle alpha. To calculate the maximum bending force estimation, uh, it is given by F equal to KBF TSWT squared over D. So where F is the bending force, TS is the tensile strength of the sheet metal, W is the work part in direction of the bend axis. Okay, so like the one that we look into the picture previously, and T is the stock thickness. V bending, for V bending, KBF will be 1.33, and for H bending, KBF will be 0.33. And for the D value is given by the die opening dimension. For V die, it is calculated by this area. Okay, so this is the dimension for the D, and for the wiping die for the edge bending, it is from this here to this area here. Okay, so this is the D value. So here are some video on the bending and shearing and also the V bending. You can look into the process to understand more on this topic. So that's the end for the sheet metal working process on the shearing and also the bending process. We will continue on the deep drawing process after this.